In this video, I will show you how you can solve any quadratic equation from scratch without the quadratic formula. The method is completing the square. At first, we need to do some important preparations like this. We have these two rules, and these rules tells me how to square a binomial. You probably know why these rules works, but I show you very quickly. We have a plus b and we square it. That means that we take a parenthesis with a plus b and multiply with another parenthesis also with a plus b. And then both terms in the first parenthesis should multiply with both terms in the second parenthesis. So first we have a times a, it will be a squared, then a times b, and then b times a, and I write it like ab, and then b times b, which means b squared. And then the two terms in the middle, they will equal 2ab, and then we have the rule. Two quick examples. X plus 4 squared. And if we follow the first rule here, then we can first take the first term and square it, like x squared. Then we have the double of the product, so we have 8x, and then we take the last term and square it. Here is how to expand this one. Another one, we take x plus 3 and square it. First x squared, then plus 6x, and then minus 9, 3 squared. So here is an important thing. Look at this equation and this number 8 here, and compare it to the number 4 inside the parentheses. You can see that the number 4 is half of the number 8. Okay, the last equation. Compare this number 6 and the number 3. You can see that the 3 is half of the number 6. And then you take the first rule here, 2b, compare it with b inside the parentheses, and then you can see that b inside the parentheses, of course, must be half of 2b. So we should use this fact that tells me that the number inside the parentheses, the last term, is always half of the size of the coefficient before x in the expanded expression. Now it's time to complete the square. We have an example. Solve the equation x squared plus 6x plus 2 equals 0. So take the terms involving x, then add something, and in a moment I will tell you what. Then subtract the same thing again. So we have added and subtracted the same thing, and then we have added, of course, exactly 0. So this line is exactly like the line before. If you add something and then subtract the same thing, you have changed nothing. But take now the first 3 terms in this row and think. These 3 terms, you can write them like a parenthesis squared, like this. If you look carefully at the first row or at the 2 examples here from right to left. We have here x squared plus 6x and plus 9. This is almost what we have here. And I know that the thing inside the parentheses, this last term, is always half of the coefficient before x right here. So if we have the number 6 here as our coefficient, then the parentheses must contain a plus 3 at the end. So I know that my parentheses must be like this. We have x plus 3. Then I know what I added. The things that I added was, of course, this number 9, because it is the same row here. It was the last term squared. It always is. It's exactly this rule. b squared is the last term squared. So the number 3, if you take it and square it, then you get 9. But then I subtract 9 as well, so I have changed nothing. These 2 terms equals minus 7, so you can of course add 7 to both sides like this. And then you have like this. You take the inverse to squaring, it's the square root, and you do it from both sides. And then you cancel square root and exponent. You have x plus 3, and then you must write plus minus square root of 7. It's important to get both solutions here. And then you subtract 3 from the left and from the right, and then you have it. X equals minus 3 plus minus square root of 7. And you can, of course, write them separately as well. Now it's time for one more, I think, a little faster. Okay, so we have x squared minus 8x plus 1 equals 0. At first, I write my two terms involving x like this. Then I look at the coefficient. I look only at the number 8 here, and I know that inside the parentheses I must have a term that is plus 4. 4 is half of that number 8. And then the last term here in my expression, the term that I will add, is that number 4 but squared. So I take half of the number 8 and I square it. So if I take 4 squared, it will be 16. Then I must subtract 4 squared as well. So I have added exactly 0. And then, of course, it will be plus 1 equals 0. Okay, so my three terms here, the first ones, I can rewrite them as a parenthesis like this. X minus, and then next term should be half of the number 8. So it will be 4, and then squared. Then we have minus 16, and plus 1, it will be minus 15. And of course, I can add 15 to both sides, and then I only have the parenthesis squared at the left, and then 15 at the right. I take the square root on both sides. I remember to write the plus and minus sign at the right here. And then I add 4 to both sides. And then I have my solutions right here. X equals 4, and then plus minus square root of 15. And I can write them separately as well. Now it's time to take a little harder equation. 2x squared minus 6x plus 4 equals 0. And at first, I don't like this coefficient before x squared, because I can't take the square root of this one in an easy way or something. So my solution is to divide all terms by 2, like this. So we have x squared minus 3x plus 2 equals 0 instead. And this one, I like it much better. Now I look at my number 3, and I know that if I take half of 3 and then square it, then I will get the terms that I will add as my extra term. So my first two terms are the same as we have before, and then I will add the square of 3 halves, like this. I will subtract the same thing, and then the rest is exactly the same, of course. My 3 first term can I write as a parenthesis and square it. So we have x, we have a minus sign in this one, and then we have half of this number 3, and it is, of course, 3 halves, like this. Then we subtract with 3 halves, but I can write it like 9 quarters instead, because 3 raised by 2 equals 9, and 2 raised by 2 equals 4. So we subtract with 9 quarters, and then I make quarters of this number 2 also. So I can write an number 1 in the denominator, and then expand it to quarters, and get 8 quarters of this one. And then it will be equal to 0. The two last terms, of course, will be equal to minus 1 quarter. So I can write that. And then I add 1 quarter to both sides of the equation. At the left, I only have the square left, like this. And at the right, I have 1 quarter. And then I take the square root of both sides. And of course, I cancel the square root and the exponent with each other. Now I only have x minus 3 halves at the left, and at the right I have the square root of 1 quarter, And then I can take the square root of 1 equals 1 and square root of 4 equals 2. So I can write it like plus minus 1/2. And I can't forget to write plus minus. It's very important, of course. And then I add 3/2 to both sides at the equation, and then I got my solutions. X equals 3/2 plus minus 1/2. And this one, you can write it easier if you separate these two solutions from each other. The first solution, you have 3/2 plus 1/2, it equals 4/2, and this will be equal to 2. And the second solution, if you take 3/2 minus 1/2, it will be 2/2, and then it will be equal to 1. So the two solutions are 2 and 1. But why is this method called completing the square? I go back to the first example where I had these two terms, x squared and plus 6x. If I split the 6x, I can replace it with 3x and 3x. And then I can actually draw a square. First, I draw a little square with side lengths x. So x, and the area is of course x squared. And if I split this term in two, then I can put a rectangle like this. I have the side length 3 and x. So here we have half of this area. We have 3x. And then we have another rectangle like this. And it is the same rectangle, but I have rotated it. And this also have the area 3x. So to complete the square like this, you need an extra bit. You need this little thing right here. The side length is of course 3 and 3, and then the area will be 9. So if you have an expression like this and the last term is plus 9, then it is exactly a square, because the whole square here has the area x plus 3 on this side and x plus 3 on this, and if we multiply them together, it will be x plus 3 squared, like this. So the whole expression is equal to this one. So if you can add these areas separately, it will be exactly like the whole area. If you like this video, please give it a thumbs up. It's really hard to get a small channel like this to grow, and please interact with this video in all possible ways. Then the algorithm will love you. I will too as well. See you in the next video. My name is Jonas, by the way, a Swedish math teacher.